The next control structure is the repeat and break control. In life, we're reading at night. I'm going to read this page, then the next page, then I'm going to repeat, read the next page, and I'm going to break when it's time to go to sleep. In R, I'm going to take random numbers. I want random numbers from the interquartile range of a normal distribution. So let me take one, add it to my list if it's in the interquartile range. And when I have 100 numbers from the interquartile range, I'm going to break. So what you do here is keep repeating until you meet a certain condition. If you think about it, this is the opposite of a while loop. A while loop repeats while the condition is met. A repeat and break repeats until the condition is met. Let's take a look. Let's walk through my code here and see what it does. First, I'm going to set my nums to null. In other words, I'm creating an object with nothing in it. Now look at this. This is using QNorm, meaning I want a quantile on the normal distribution, and I want that quantile to have 0.25 or 25% beneath it. It's going to be from a normal distribution with a mean of 50 and a standard deviation of 10. So if I set that, you can tell by looking over here, 43.26, that is the first quartile of a normal distribution with a mean of 50 and a standard deviation of 10. I'm going to use the QNorm to obtain the third quartile, and we'll call that the upper bound. Why lower and upper bound? Because together, the 43.26 and the 56.74 make up the boundaries of what we know as the interquartile range, from the first quartile to the third. This is the middle 50% of the values in the distribution, and in this case, the distribution is a normal distribution with a mean of 50 and a standard deviation of 10. All right, so here's what I'm going to do. I'm going to repeat, and again, we have these brackets. So notice I have a curly bracket here, but the curly bracket that ends on line 196 is not for the one on 191. Inside, I have an if condition. And so this 196 is the end to this curly bracket on 194. Those are the inner brackets. I'm going to go all the way down to, let's see, not even this one, not the one on 200. That's another if statement. And so this inner bracket goes with this inner bracket on 198. So 198 goes with 200. 194 goes with the bracket on 196. Finally, at 201 is the bracket that corresponds to 191. If you want to draw this out, if you want to print this and make a pencil drawing, you'll see that these two match up here on 194 and 96, 198 and 200 match up, and so we have to go all the way from 191 to 201. That's my repeat statement. So I'm going to keep repeating in here until I break. And that break, as I can see looking ahead, is going to be based upon a condition. So let's repeat. We're going to take a random number from a normal distribution. We're just going to take one of them. Mean of 50, standard deviation of 10. All right, so we grab that from a normal distribution with a mean of 50, standard deviation 10. Now I look at that random number and I ask, is it greater than the lower bound and less than the upper bound? In other words, is it in the interquartile range? If it is in the interquartile range, I'm going to concatenate it with my nums. Now you can see why I set my nums here equal to null. If I had not established my nums as an object, what would R do when it saw me concatenating with my nums? It would give me a message saying, there is no such thing as my nums. So what I did is I fooled R. I created my nums, but I didn't put anything in it. But now I'm going to put that first number in from the interquartile range, assuming it is from the interquartile range. And I'm going to now change the mynums vector to be this concatenation. Now you see what happens every time we repeat around, that if it's in the interquartile range, it will be added to the list. So we're going to keep adding to this list. Now, when we go to line 198, after we have concatenated with the list, we check. Do we now have 100 values in mynums? Is the length of mynums equal to 100? If so, what are we going to do? Break. That's the end of the repeat loop. When we break, we'll come all the way out past line 201. We'll be done. But if length mynums is not 100, we're going to go back up here and we're going to keep repeating. This will give us 100 numbers from a normal distribution with a mean of 50 and a standard deviation of 10 that are within the interquartile range, or in the middle 50% of that distribution. All right, let's do it. And it's done. Look at mynums. It says it's 1 to 100. All those numbers there, if I went ahead and printed them all out, all those numbers in mynums are in the interquartile range. Think about that. 50 with a standard deviation 10. Notice how they're all kind of clustered around 50? That is, they're in that middle 50%. Now, as with the while loop, you have to be careful with repeat loops. Look at this code below. What do you think this will do? I'm going to set I to 0. Let's go ahead and do that. So now I set I to 0. And now what am I going to do? I'm going to repeat this loop. I equals I plus 1. Well, I is 0, but now it's going to become 1. I is going to become 1, and it's going to print it. Then it's going to loop around. Now it's going to be 1 plus 1 is 2. And print it, and loop around. And then 3, and loop around, 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 and loop around. Do-doom, 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 do-doom. So there's no break here. It's not going to break. All right, this is going to make our computers explode. No, we don't have to worry about that. But what we are going to have to do when we start this is we're either going to enjoy looking at those numbers go by and maybe ask ourselves, how long will this go on? Let me go grab a sandwich. Or we can go up here to this little stop sign and click on it and end the loop. But I had to manually end the loop. It did not end on its own. And it even gave me that little error bar because it didn't finish. It says, hey, you stopped me. I didn't finish. I'm going to give you an error. I'm not going to let it finish because I don't have that much time. Now the break, which as we just saw for a repeat is very important to have, that break can actually be used in any type of loop, though the most common place we use it is with the repeat function, but I'm going to show you here that we can use it anywhere. So here I've got a for loop going on. Notice the curly bracket on 217 matches with the one on 223. So the end of the for loop is on 223. What is this going to do? For I in 1 to 100, it's going to start out I with 1. It's going to print 1. Then it's going to come down and say, is I greater than or equal to 50? And if so, it's going to break. It's going to quit. So this is a little bit silly because what it's going to do is it's going to loop back around and do 2, 3, 4, 5. And even though I have the for loop set to go 100 times, it's going to stop before it gets there. It's going to stop once I is greater than or equal to 50. So let's run it. There it is. It just printed out from 1 to 50. And all I did there was demonstrate that you can use the break in other kind of control structures, but the repeat is most often where it's used.